curvature and arc lengths. First problem is to sketch the given curve and find the length over this interval. So give you r of t, the position vector. It's ti plus 3tj. The interval from 0 to 4. So let's sketch it. Remember, that's x of t. That is, x is t. And y is 3 times t. But t can be replaced with x. So y is equal to 3x. And we know what y equals 3x looks like. It's this line right here. It crosses the origin. It has a slope more than 1. Let's make up a little table. Let t be 0 and 4. So we can find the start and the finish. Because it may not be, it's not going to, most probably it's not going to be the case that we're going to keep this whole line. Well, remember, whatever t is, that's what x is. So if t is 0, then x is 0. And if t is 4, then x is 4. And y is 3 times t. 3 times 0 is 0. 3 times 4 is 12. So we're only going to keep the portion that goes from 0, 0 to the point 4, 12. We're only going to keep what's in between. That is, this is history. So there it is. Now we want to find the length of this. Well, there's two ways to do this. This is our high school, this is, we can use the distance formula. This point right there, 0, 0. This point up here is 4, 12. So you do 12 minus 0 and you square it. That is, you subtract the y's. You do the same to the x's. You square it. You add them up. The distance, which is denoted by s, is 12 squared. 12 minus 0 is 12. Square it, get 144. 4 minus 0 is 4. You square it, you get 16. You add up those two numbers, you get 160, which is 16 times 10. So it's the square root of each of them. And the square root of 16 is 4, and the square root of 10, I don't know. So the length is 4 square root of 10. That is one way to do it. In fact, that's the way I think you should do it. But to practice the calculus, you have that the arc length is from 0 to 4 of the length of r of t, r prime of t, dt. Well, let us calculate what r prime of t is. Here's r of t up here. The derivative of t is 1i, plus the derivative of 3t is 3j. So the length of r of t is 1 squared plus 3 squared square root. But of course 1 squared is 1 and 3 squared is 9. 1 plus 9 is square root of 10. So we get square root of 10. That is, we have, so now this is a constant. It's square root of 10. I can bring it in front. The square root of 10 times the integral from 0 to 4 of dt. 1 dt in particular. The integral of 1 dt is t from 0 to 4. Well, first you plug in 4, you get 4 minus. Then you plug in 0, you get 0. 4 minus 0 is 4. So you get the square root of 10 times 4. Better known as 4 square root of 10. It took a lot longer. I mean, we actually had to do this calculation. The integral maybe wasn't any longer than using the distance formula. But you really didn't even have to find r prime or the length of r prime. But you could. And we did, and we got the same answer. Let's try one more like this. Suppose you come to know that R of t, suppose you come to know that R of t is defined as follows. The sine of t minus t times the cosine of t, cosine of t plus t sine t. Suppose you have this, and you want to know the interval is 0 to pi over 2. 0 to pi over 2. Let's find the arc length first before we graph it. So we need to find r prime of t. Derivative of sine of t is cosine t minus the derivative of this, which is a product. First is t and then cosine t. The derivative of the first times the second plus the first times the derivative of the second, comma. I'll write it down below. The derivative of cosine of t is negative sine of t plus first times second. The derivative of t is 1 times the second function plus t times the derivative of sine of t, which is cosine of t. Okay. So we have cosine of t, and we are going to take away 1 times cosine of t, which is cosine of t. So that difference is 0. Cosine t minus cosine t is 0. Remember, this is really minus t sine t. Minus t sine t. So we have to take that away. So we get positive t sine of t. This is sine of t. Negative sine t plus sine t is 0. And now we have to add on positive t cosine t. So that is the derivative. So we can now find the length of r prime of t. You square this plus you square this. Take the square root of that. You can factor out a t squared from those two terms, and what's left over is sine squared t plus cosine squared t. But that's 1. That is, it's just the square root of t squared, which is not t. It's the absolute value of t. So now we have r prime of t, the magnitude. It's the absolute value of t. And we want to know the arc length of this function from 0 to pi over 2. So the formula says that the arc length is the integral from 0 to pi over 2 of r, the magnitude of r prime of t, which is the absolute value of t dt. But these are t values. T goes from 0 to pi over 2. And for all values in between, 0 and pi over 2, t is either 0 or positive. T is either 0 or positive. That is the absolute value of t. In this interval is just t. It's just t. Because I'm integrating across positive numbers. You go from 0 to pi over 2, you're never negative. And the integral of t, t squared over 2. From 0 to pi over 2. So everything's over 2. That's 2. You plug in pi over 2, you get pi over 2 squared over 2 minus, then you plug in 0. 0 squared over 2, which is 0. So you get pi squared over 4. Pi squared is pi squared and 2 squared is 4 over 2. I don't care what that is on top. If you divide it by 4, then you divide it by 2 again. You divide it by the product. 4 times 2 is 8. Here's the answer. Somebody gives you the number, I don't know, 72. And they ask you to divide it by 4. And you're like, oh, you don't have a calculator, you don't have pencil and paper. Well, what you can do is think of numbers and multiply out the 4. Like 2 times 2. Possibly you can do that division in your head, and then you can do 36 over 2 in your head. So you can get the answer. You may not have to run and get a calculator. Okay, now we want to graph this from 0 to pi over 2. So we found the arc length, now we just have to graph it. Remember that r of t was equal to the sine of t minus t cosine of t, comma, the cosine of t plus t sine t. Remember that the sine of pi over 4 is equal to the cosine of pi over 4, which is square root of 2 over 2. So what I'm going to do is, so remember, that's x and that's y. I'm going to make up a table. T, and then I'll find x and y. I'll choose t's, and I'll calculate x and y's. And of course, t goes from 0 to pi over 2. Let t be 0. Let it be pi over 4. Eventually, let it be half of pi. The sine, I'm right here, the sine of 0 is 0. And this, when t is 0, is going to be 0, because 0 times anything, in this case 1, is 0. 0 minus 0 is 0. Let's find the y value at 0. The cosine of 0 is 1. But this part's going to be 0 because you're multiplying by t, which is 0. So you get 1. Let's go to pi over 2 next. The sine of pi over 2 is 1. That means if the sine or the cosine of some angle is, the sine is plus minus 1 at some angle, and the cosine will be 0. Vice versa. When the cosine is plus minus 1, the sine is 0. So at pi over 2, the cosine term is 0. So for x, you just get the sine of pi over 2, which is 1. And for y, you just get pi over 2 times 1, which of course is pi over 2. Okay. Now let's take on the middle one, pi over 4. X. You have the sine of pi over 4, which is square root of 2 over 2, minus t, which is pi over 4, times the cosine of t, which is square root of 2 over 2. I am going to factor out the square root of 2's. So what's left over is 1 minus pi over 4. 1 times square root of 2 is the same as square root of 2 over 2. Excuse me. 1 times square root of 2 over 2 is the same as square root of 2 over 2. I factor this out. I'm left off with 1 minus pi over 4. That's what's left over. So that's their x value. 1 minus pi over 4. Now the y value. Cosine of t, or cosine of pi over 4 is that, plus, let's say plus, then it's t, pi over 4, times the sine of pi over 4, which is square root of 2 over 2. 1 times it. So when I factor out what's common, I'm left with 1 plus pi over 4. Square root of 2 over 2 times 1 plus pi over 4. And we plot this. T is going from 0 to pi over 2. And make sure of that. Let's get rid of most of this. This was pi and that was 1. Okay, so we plot this. When t is 0, we get the point 0, 1. When t is pi over 2, y is pi over 2. The numerator is more than 2. Approximately 3.14. So when I divide, I get by 2, I get more than 1. That's why I want above 1. And it's right here. And it turns out that the square root of 2 over 2 times 1 minus pi over 4 is less than pi over 2. Work it out. You'll see that. It's less than pi over 2. And the y value is going to be between 1 and pi over 2. I mean, that's maybe what a calculator is used for. So it's right here. What happens is the graph looks just like that. Okay, but it starts at x equals 0 and it finishes at x equals pi over 2. Okay, so we found the length of that arc and we drew the arc. The way I said it, we found the length of it. Possibly I should have drawn it first so we could look at what we're finding the length of. Okay, the next problem is they want us to find a curvature. Y is equal to 3x plus 2. We want to find the curvature at A. So y is a function of x. And when you have y as a function of x, the curvature, which is denoted by k, is y double prime, the absolute value of that, divided by 1 plus y prime squared, and that whole denominator gets raised to this 3/2 power. So I need to find y prime and y double prime. Well, y prime is 3, and y double prime 0. And this is y double prime at x. Y prime at x. Y double prime at x. So y prime at A, well, it's a constant function. Y prime is a constant. It's always 3. Same with y double prime. It's a constant function. Happens to always be 0, but it's still constant. So what we get is y double prime absolute value. The absolute value of 0 is 0. The bottom will never be 0. Because when you square y prime, it won't be negative. And then you add 1 to it, it will be at least 1. So it won't be 0. But in any case, we get 1 plus y prime of A is 3, which gets squared. And all of this to the 3/2 power. And you want to work it out. This is 9, this is 1. So you get 10 to the 3/2 power. But it's 0. The curvature is 0. Now, let's also find the radius of curvature. The radius of curvature is 1 over the curvature. And this is undefined, because you can't find the reciprocal of 0. 0 over 1, the reciprocal is 1 over 0. You can't divide by 0. Why? Because it's undefined. Okay, let's find another curvature, and then the radius of curvature. Do a couple of problems in each. Y is equal to 2x squared plus 3. And here we're going to do it at -1. So then y prime is 4x, and y double prime would be 4. So y prime at -1 is -4. And y double prime at -1, well, it's a constant. It doesn't care what x equals. X can equal 1, it can equal 1,000,000, it can equal -1. Y double prime is going to be 4. And the formula again is the curvature is the absolute value of y double prime divided by 1 plus y prime squared, and then raise that to the 3/2 power. So y double prime, the absolute value of 4 over 1 plus this squared, y prime squared, 16. All to the 3/2 power. So you have 4 over 17 to the 3/2 power. And I don't know the second root of 17, so I can't simplify it. But the radius is the reciprocal of the curvature. So it's going to be, just flip it over, 17 to the 3/2 divided by the number 4. And that problem is done. Just have to know the formula. So let's try one more. This one looks interesting. Suppose you have y equals a squared minus x squared to the half. You want to do this at x equals 0. So y prime. Y prime is you keep the function the same, you bring down the power, you make the new power 1 less. A half take away 1 is -1/2. Then you multiply by the derivative of what's inside, which is -2x. Half times 2, that vanishes. What stays is the -x in the numerator, and this is in the numerator, but it has a negative exponent, so I'll put it in the denominator, and I'll change the sign of the exponent. So now y prime of 0, well, it's going to be 0. The bottom is going to be a squared to the half, which is not 0. But the numerator is 0. So y prime with 0 squared is 0. So that's one piece we need. Now let's go and take the second derivative. I'm going to take this from here, but I'm going to factor out that negative sign. Y double prime is negative. Now I use the quotient rule. It's the derivative of the top, which is 1, because it's just x on top now. I factored out this negative sign, times the bottom, minus the top, which is x, times the derivative of the bottom. Bring down the power, keep the inside the same, make the new power 1 less, and take the derivative of what's inside. After all, we just took the derivative of the bottom. and I took the derivative of y. And all of this gets divided by the denominator squared. If you have the square root, then you square. There is no more square roots. Okay, let's clean this up a little bit. Here's that famous negative sign. 1 times that is just that. A squared minus x squared to the half. That means square root. This negative comes in front, makes it positive. So I dealt with that. Half times 2, history. It's 1. X times x is x squared. And this piece having a negative exponent, it goes in the bottom as the square root of a squared minus x squared. And all of it is still being divided by a squared minus x squared. Now if you clean this up, and this is just algebra, you get a squared minus x squared plus x squared divided by a squared minus x squared to the 3/2 power. And negative x squared plus x squared cancels out. Now, if x is 0, you get negative a squared on top. If x is 0, this is not there. So the bottom gives you a squared to the 3/2. And let me go to the top right, please. So the numerator is a squared. The bottom, when you multiply these powers, which you're supposed to do, the 2's cancel out. So you get a cubed. So this is negative 1 over a. That is y double prime of a. Let me write that down while I erase this mess. I meant to say y double prime at 0. So y double prime at 0 is negative 1 over a. With these two pieces, I claim we can do it. K is equal to y double prime divided by 1 plus y prime squared, all to the 3/2 power. Well, y double prime, the absolute value is 1 over a. 1 over a. Then we divide by 1, because y prime is 0. Square is 0. So the bottom is 1 plus 0, which is 1 to the 3/2 power. For 1 to any power is just 1. And the rule for dividing by 1 is don't bother. So you just get what's on top, 1 over a. Which tells me that the radius, 1 over k, is the reciprocal of that, which is a. There is a nice problem. Just messy having to take these derivatives, but that's not really Calc 3 anymore. That's something that you're experts in. That's Calc 1. Okay. Let us look at this function. F of x is equal to sine x. Let's just look at part of it. Well, here's part of it. And here is the point pi over 2, comma 1. X-axis, y-axis. Now, I put a circle in here. I get a circle in there. So that's the circle of curvature to the graph. Now I want to find the equation of this circle. I want to find the equation of the circle. So first I want to find the curvature. So we know that y is equal to sine x, and y prime is cosine x, and y double prime is negative sine x, and y prime at pi over 2 is cosine of pi over 2, which is 0. Cosine of pi over 2 is 0. And y double prime at pi over 2, that is negative the sine of pi over 2. Well, right above, I have the sine graph, and at pi over 2, the y value is 1. 1, with a negative in front. So now, the curvature is our y double prime squared y double prime is negative 1. You square it, you get 1. The bottom is 1 plus y prime squared. Well, y prime at our point is 0. You square it, you get 0. And this is to the 3/2 power. So you have 1 over 1 plus 0 is 1. And 1 to any power is 1. So we get that the curvature is 1. For the next moment, let's think of 1 over 1. So the radius of curvature is the reciprocal of this. The 1 on the bottom goes on the top. The 1 on the top goes on the bottom. We get 1. Our radius is 1. Okay? So what I know is that this point, this length is 1. That length is 1. Which says to me a couple of things. One, I didn't draw the picture very well, but that's neither here nor there. The radius is 1. So I go down 1. And that brings me to pi over 2. The x won't change when you go down. And the y was 1. When you take away 1, it's 0. And now that I have the center, and I have the radius, the center is pi over 2. The radius is 1, so I can write the equation. The center is pi over 2, 0. The center is y minus 0, all squared, which is just y squared, plus x minus pi over 2 squared, which is x minus pi over 2 squared, and this is equal to the radius squared, which is 1. And there is our equation of the circle of curvature to that graph. Okay, the fact that the derivative was 0, that told me to go perpendicular to their tangent line. This is the tangent line. It told me to go perpendicular one space, a length of 1, because the radius was 1. Okay, but it may not always be that way. May not always be that way. Let's consider the next problem. Suppose we have y equals e to the x. If you think about y equals e to the x, you know that the derivative is never 0. It's an increasing function. Suppose you have y equals e to the x, and we're concerned when x is 0. That implies that y is 1 because e to the 0 is 1, which equals y. So basically what's going on is, here is the graph e to the x. And here is the point 0, 1. What's going to happen is, I want to draw a circle of a particular radius that's tangent to that line. That is, I want to find the equation of this one. The center is going to be perpendicular to the tangent line. The center is going to be right there. So there's a lot of work to be done here. I know that if y is equal to e to the x, then y prime is e to the x, and y double prime is e to the x, and y at 0 is 1, y prime at 0 is 1, and y double prime at 0 is 1. So the curvature is going to be straightforward. The curvature is y double prime, which is 1. The absolute value of that. The absolute value of 1 is 1. Divided by 1 plus y prime squared. Y prime at our point is 1. You square it, you still get 1. And this is to the 3/2 power. And of course 1 plus 1 is 2. So here is the curvature. Now 1 1/2 is 1 plus 1/2. Well, here's 2 to the 1, and here's 2 to the 1/2. If I multiply top and bottom by square root of 2, that is, if I multiply by 1, 1 times square root of 2 is square root of 2, and 2 square root of 2, times another square root of 2 is 2, times yet another 2 gives you 4. That's the curvature. This tells me that the radius, now I'd rather take the radius from here. The radius is 2 over square root of 2. That is, this line right here, this line right there is 2 square root of 2 units in length. Okay. Now, what I'm going to do is I'm going to find the equation of this line. I'm going to find the equation of this line. Remember, we know that point right there, we found it on top, that point right there is 0, 1. Using that point, I'm going to find the equation of the line. And then I'm going to find a point on that line whose distance is 2 square root of 2 from that point 0, 1. Okay. Now, I know the slope of this line is 1. After all, y prime of 0 is 1. That tells me that the slope of the perpendicular line is -1. So I have a slope, I have a point. The equation of that green line is, call it y perpendicular. It's mx plus b. I actually have b. That line, that green line, crosses the y-axis at 1. It crosses the y-axis at 1. Plus 1. So I have the equation of the line. Okay. So now, what I want to do is, I want to find the distance between 0, 1 and another point. I want to calculate the distance between 0, 1 and the arbitrary point right here. Right there, we'll call it xy. I want to calculate the distance between xy and 0, 1. So it's y minus 1. But this is just another way of writing y. This is another way of writing y. It's y minus 1 squared plus x minus 0 squared. Well, x minus 0 is x squared. And I want it to be 2 square root of 2 squared. I want the distance to be 2 square root of 2. Well, 1 minus 1 cancels. Negative x squared is x squared. Plus another x squared. That's 2x squared. And this is equal to, well, 2 squared is 4 times the square root of 2 squared is 2. I'm going to leave it just like that. 2 times this is equal to 2 times 4. So x squared is 4, so x is plus or minus 2. Now, I hope it's clear that at the point xy, at this point right here, x is not positive 2. Positive 2 would be there. It's more, has a better chance of being negative 2. So we reject the positive 2. Y equals negative, x is negative 2. But we can find the y value. I just used the rule. It's negative 1 times negative 2, which is positive 2, plus 1. 2 plus 1 is 3. See, now I know that point. It's negative 2, 3. I now know that point. Okay. I know that point and I know the radius. Okay, I know the center and I know the radius. So let me get rid of most of this, at least the right half. And again, I know xy, which is the center. I know the center. The center is negative 2, 3. And I found the radius. It's 2 square root of 2. So the equation is going to be x minus the x value of the center, negative 2 squared, plus y minus the y value of the center squared, and that's going to equal 2 square root of 2 squared. It's going to equal r squared. I'll clean it up. This just becomes x plus 2 squared plus y minus 3 squared. 2 squared is 4. Square root of 2 squared is 2. 4 times 2 is 8. There is your equation. Okay, it's tangential to the point in question, 0, 1. And it has a particular radius, 1 over the curvature. Not an easy problem, but my opinion, it's a fun problem if you see it. If you didn't see the steps, you're like, oh boy, this problem is brutal. What is this guy doing? Absolutely, I agree with that. Let's try one more. Suppose you have y equal 1 over x plus x. You want to find the circle of curvature to that graph at x equals 1. Well, if x is 1, 1 over 1 is 1, plus 1 is 2. So y is 2. So you have a point. And I'll give you what the graph looks like. Pretty much looks like that. All 4 endpoints go on forever. This goes down forever, that goes down, this goes up, and so does this. It turns out that the point 1, 2 is right there. If you think about it, if x is positive, the least this can be if x is less than 1, if x is less than 1, then this here will be more than 1. And then you add on a little bit more, it'll be more than 1. If x is bigger than 1, then this is bigger than 1, and you're adding on some more. Less than 1 more, but you're going to have more than 1. Now 1 is the lowest point. And for the record, the left half will be negative 1. Okay, so nonetheless, we now know where 1, 2 is. Let's find the derivative right there. That's important. The derivative of 1 over x is negative 1 over x squared plus the derivative of x is 1. I'm going to write the 1 first. So I like to know where this equals 0. Okay, when does y prime equal 0? Well, this must be 1. 1 minus 1 is 0. So 1 over x squared must be 1. The numerator is 1, then the denominator must be 1. So x is either plus or minus 1. In particular, 1. At 1, the derivative is 0. Okay, so we now know that the tangent line at our special point, the point 1, 2, is 0. That is, here's the horizontal line. Now, that means the center is going to be here. The center is going to be along that line. And the equation of that line is x is equal to 1. The question is, how far up is the radius? Okay, the radius is going to be right there in green. If so, remember, at the point right here, y is 2. If the radius is 5, I go from 2, from a height of 2, I have to go up 5. That is, I'm just going to add the radius to 2. It's going to be 2 plus whatever the radius is. So let's find the curvature. Let's find the curvature. Okay, so y prime of 1, well, 1 over 1 squared is 1. 1 take away 1 is 0. Now we need to find the second derivative. Remember, this first derivative is 1 minus 1 over x squared, which I'll write that way for now. So y double prime of x, well, the derivative of 1 is 0. Bring down the power, you get positive 2x to the negative 3. So since there's negative 3 on x to the negative 3 on top, I'll put x to the 3 on the bottom. And then y double prime of 1, well, 1 cubed is 1, 2 over 1 is 2. So now, if I'm not mistaken, we're in the position to find the curvature. It's y double prime at 1 divided by 1 plus y prime squared at 1, or to the 3/2 power. Well, y double prime is 2 over 1 plus y prime of 1 is 0. 0 squared is 0. 1 plus 0 is 1. To the 3/2 is still 1. So you get 2 over 1. That tells me that the radius is the reciprocal of this, which is a half. The radius is a half. That means this distance that I'm putting in green now is a half. You're at 2, you add a half, so now the center is going to be 1 comma 5/2. 2 plus a half is 5/2. So, and again, the radius is a half. So armed with the center and the radius of the circle, it's done. It's done. You have the center of a circle and you have the radius. You can't ask for more. So it's y minus the y value squared plus x minus the x value, which is 1 squared, and this is equal to r squared. Square 1, you get 1. Square 2, you get 4. 1/2 squared is a quarter. That should be a 2. And here it is. Of course, you could have written the x minus 1 squared first. Could have said x minus 1 squared plus 5 minus 5/2 squared equal to a quarter. And it's exactly the same. Addition commutes. Okay. We need to find the equation of that line that is perpendicular to the point of tangency. And then your circle will be there. Again, if you have some curve and say right here you want to draw a circle of curvature, well, first you need to find the slope of this line. Call it M. Then you find M perpendicular. So now you know the slope of this line. Well, you have this point because you have f of x, and they tell you the x value, and they don't tell you the y value. Compute f of r in this case, and you get s. So we have our point, and we have the slope of this lightly red line, not the bold line, not this one. So if you have the slope of this line, and you have a point on that line, you can find the equation of the line. Y is equal to mx plus b. Okay. So what you do is you pick a point on the line, x, comma, y. But this is how you write y. And then you find the distance. Subtract the y's, mx plus b minus s, square it, plus subtract the x's, x minus r, and you square it. And this is supposed to be the radius squared. So you find the curvature, take the reciprocal, and you have the radius. You don't want to take the reciprocal, fine. Don't find the curvature, find the reciprocal of the curvature. That is, instead of finding k, find 1 over k right away, which is our 1 plus y prime squared to the 3/2 divided by y double prime in absolute value. That will give you the radius. You need to think about how this is done. That way you can do all the steps without making an error, well, a non-calculation error. Suppose now they ask you to find the curvature, but it's not y is a function of x, but rather r is a function of t. They tell you that r is 4ti, and they want to know the curvature when t equals 2. So now we have a completely different formula. The curvature is the length of t prime of t divided by the length of r prime of t. Okay, so let's find the denominator. Let's find r prime of t, the length of it. Well, r of t is 4. So the length of 4i is going to be 4. I mean, think about it. This is 4 plus 0, j. You go out 4, in the I direction, and you go 0 in the J direction. That brings you right here. The length is 4. And you want to do 4 squared plus 0 squared and get 16 plus 0, square root of that. 16 plus 0 is 16. Square root of 16 is 4. Fine. You got it. The length of R prime of t is 4. Now we need to find t prime of t. T of t is T of t is R of t divided by the length of R of t. I meant to say R prime. So R prime is just 4i. R prime is 4i. And the length of R prime is 4. We get 1i. We get 1i. Now, t prime of, well, actually, okay, so t prime of t would be, remember, this is plus 0j. So derivative of 1, which is 0, I, plus the derivative of 0 is 0j. This is a 0 vector. The length of the 0 vector is 0. 0 over 4 is 0. And that's the curvature. The curvature is 0. Do another one of this form. Give you R of t. I'll ask you to find the curvature. Suppose you come to know that R of t is, say, 4t squared I. You want the curvature when t is 4. When t is 4. R prime of t is 8t. R of t magnitude, RTI, it's going to be 8t. In fact, it's going to be 8 times the actual value of t. Alright, so now we want to find, we really want to find R, the length of R prime at t equals 4. Which is 8 times the absolute value of 4, which is 32. In fact, let's not even do that yet. Not even do that yet. And remember, the curvature is the length of t prime of t divided by the length of R prime of t at a particular value. Possibly things will cancel out, so we don't have to do any substitution. Now, t of t is equal to R prime of t, which is 8ti divided by 8 times the absolute value of t. But since t is 4, we know that's going to be 1. If t were negative, I would call it negative 1. So we get 1i. 1i plus 0j. So t prime of t is just going to be the derivative of this, I, plus the derivative of that j. It's the 0 vector. And the length Well, let's do it here. The length of the 0 vector is 0. So we have 0 over 8t. 8 times the absolute value of t. And if t is 4, we get 0. So now I'm plugging in at the very end. We still get 0. But in fact, so long as t is not 0, I don't even have to plug in. I can say, well, as long as t is not 0, I get 0. And t is not 0. T, after all, is 4. So my opinion is to find k as a function of t and then plug in the value for t. That way you don't have a lot of as many substitutions to do. Okay, let's find the curvature of this function. You come to know that r of t is 2 cosine pi t in the I direction plus 2 times sine pi t in the j direction. So let's find r prime of t. Keep in mind the curvature is the length of t prime of t divided by the length of r prime of t. That's k of t. Then we'll plug in the value for t, which in this problem, well actually not even, they want us to do this in general. So r prime of t is, well there's the 2. The derivative of cosine of any angle is negative the sine of the angle times the derivative of the angle. And with respect to t, the derivative of that angle is pi. Plus 2 times the sine of that angle. The derivative of that. The derivative of sine of any angle is cosine of the same angle times the derivative of the angle. The angles never change. I direction, j direction. So now let's find the length. The length of this is, well, you square it. So you square this without the I. A negative squared is positive. 2 squared, pi squared, sine of pi t squared, plus you square the 2, you square the pi, you square the cosine of pi t. And you take the square root of this. You can factor out 4 pi squared. You have 4 pi squared times what I didn't underline, namely sine squared pi t plus cosine squared pi t. Sine squared of any angle plus cosine squared of the same angle is just 1. 4 pi squared times 1, of course, is 4 pi squared. The square root of 4 times the square root of pi squared. It's 2 pi. Okay, so I actually have the denominator. It's 2 pi. Now let me find the numerator. Well, t of t is r prime, which is negative 2 pi sine pi t in the I direction plus 2 pi cosine pi t in the j direction divided by the length of r prime, which we just gleaned was 2 pi. Well, for the first, the 2 pi's cancel, and even for the second. So what we get is negative, don't forget that negative sign, negative sine pi ti plus cosine pi tj. plus cosine pi tj. But I don't want t of t. I want the length of t prime. So let's find t prime of t. Derivative of that is negative cosine of pi t times pi. That's in the I direction. Plus, minus sine pi tj times pi. Okay. The length of this equals the length of that, which is the square root of this squared plus that squared. You get pi squared cosine squared pi t plus pi squared plus pi squared times sine squared of pi t. Sine squared pi t. Well, once again, you can factor out the pi squared. And what's left over is 1. Pi squared times 1 is pi squared. Square root of pi squared is pi. So that's the length of t prime. Pi over 2 pi is 1/2. It's not even a function of t. That is, it's a constant function of t. K of t is always 1/2. Doesn't matter what t is. That's why you don't want to plug in the value for t right away, because it might end up being a constant anyways. Here the numerator and denominators didn't have t. That is, the length of t prime and the length of r prime did not have t's. But even if they did, maybe the t's will cancel out. Same problem, let's find k. You suppose that you were told that r prime of t was cosine omega t plus omega t times the sine of omega t, that's x of t, comma, the sine of omega t minus omega t cosine of omega t. So first we want to find r prime. R prime of t. Well, the derivative of cosine of any angle is negative the sine of that angle times the derivative of the angle, which is omega, plus. Let me factor out the omega. So here we have a product, t sine omega t. So we have t sine omega t. The derivative of t is 1 times the second function, plus the first function, which is t, times the derivative of the cosine function, which is cosine omega t times omega. That's the derivative of the first component, comma. Now let's find the derivative of that. The derivative of sine of omega t is cosine of omega t times the derivative of the angle, which is omega, minus. And I'll even factor out the w, minus the omega, excuse me. The derivative of t cosine omega t, well, it's the derivative of the first, which is 1, times the second function, plus t times the derivative of the second function. The reason I put a minus is the derivative of the second function is negative the sine of omega t times omega. Okay, let us clean this up a little bit. Well, first I see this, negative omega sine omega t, and then I'm adding it back. So that actually cancels. So what I'm left with is t omega squared cosine omega t. I really should write the omega squared first. It's a constant. Omega squared t. Omega squared t, comma. This is going to be omega cosine omega t. But that's exactly what this is. Oops, we're subtracting them. Say bye to them. A negative times a negative is positive. And omega times the next piece will be omega squared times t times sine omega t. That is r prime. What is the length of r prime of t? In fact, maybe it's best to factor this out. Haven't been doing that lately, but maybe it's not a bad idea to factor out what's common, like omega squared t. So this here is omega squared t times cosine omega t, comma, sine omega t. So now the length of this becomes the square root of this squared, omega squared t squared, times the length of that, which is cosine squared omega t plus sine squared omega t, which is 1. So what we get back is just that, the square root of that, which is omega squared t. So r prime is omega squared t. And now we can find, so I think we need that. We need that result. So now t of t is the division of these two. It's division of this divided by the division of that. We have omega squared t times the vector cosine omega t sine omega t. And it gets divided by omega squared t. So that cancels out. That is, we just get cosine omega t sine omega t. Let me erase most of the top, please. Excuse me. So working from the last line, we can find t prime. The derivative of this, which is negative sine omega t times omega, comma, derivative of that, cosine omega t times omega. That's t prime. But the length is going to be, now, if you want, you can factor out the omega. Okay, negative sine omega t, comma, cosine omega t. So the length will be the square root of w squared, omega squared, times this squared plus that squared. For once again, that part's going to be 1. You just get the square root of omega squared, which is omega. So then the curvature is this value, which is omega, divided by the length of r prime of t, which is omega squared t. Omega goes in there one time and into omega squared, omega times. You get 1 over omega t. Okay. Nothing really hard there, just a lot of calculations, which unfortunately leaves room for a lot of silly errors. Don't miss any signs. You know, if I did, well, follow it anyways. It's just a silly error. That doesn't mean one can do it or not do it. If you make silly errors. You can make theoretical errors. That's not good. And now, the next problem is, they give you this equation, y is equal to x minus 1 squared plus 3. I want to find a point on this curve that has the greatest curvature. Okay, I want to find max k, and b, I want to find k as x goes to infinity. I want to find k as x gets bigger and bigger and bigger. I want to find k as x gets bigger and bigger. So let me find k. And well, y prime is 2 times x minus 1 to the 1 times 1. You don't have to multiply by 1 or denote it, and you don't have to put the power. That is, you get 2x minus 2. Or possibly I'll leave it like that. And y double prime is 2. Probably easier to take it from there. Y double prime is 2. Okay? So the curvature is y double prime, the absolute value. The absolute value of that is 2 divided by 1 plus y prime squared. 2 squared is 4. X minus 1 squared is x minus 1 squared. We want to raise this to the 3/2 power. Now, I want to know what the most k can be. Now, you can take the derivative of k and set it equal to 0 and find a max. But the bottom line is, the top is 2. For k to be the biggest, I want the bottom to be small. I mean, you divide 2 by a tenth, you get 20. Divide 2 by 10, you get a fifth. That is, you want to divide by the least. That is, I want the denominator to be the least. Now, you're raising stuff to the 3/2 power. If you want to be the smallest, you want this to be the smallest. The smaller that you raise to the 3/2 will give you a smaller answer. You raise a lot to the 3/2, you get a lot. Raise a little to the 3/2, you get a little. So I want what's inside those big brackets to be little. Well, my hands are really tied with 1. 1 is 1. I want this to be the least. Well, 4 is 4. You multiply 4, the smaller number you multiply 4 by, the smaller your answer would be. That is, I want x minus 1 squared to be the least. Well, the least x minus 1 squared can be is 0. That happens when x is 1. You have a max when x is equal to 1. And that k would be, this will here will be 0. 1 minus 1 is 0. You square it, you get 0. 4 times 0 is 0. 1 plus 0 is 1. Raise it to the 3/2 power, it's 1. 2 divided by 1 is 2. That's the max it can be. You want to go and take derivatives and set it equal to 0, fine. Okay, now we want to find the limit as x goes to infinity of k. the k happens to be 2 divided by 1 plus 4 times x minus 1 squared to the 3/2. Okay. Limits are very friendly. You can take the limit as x goes to 2, I meant to say infinity, of the top. And then you can take the limit as x goes to infinity of the bottom. But the bottom is something to a power. You can take the limit of what I refer to as a something, and then whatever answer you get, raise that to the 3/2 power. Okay. As x goes to infinity or to 11, the number 2 doesn't care, it stays 2. Limit to the 3/2. As x goes to infinity, x minus 1 blows up, goes to infinity, you square it, it's infinity, you multiply it by 4, it's infinity, 1 plus infinity is infinity, infinity to the 3/2 is infinity. 2 divided by really, really large is 0. You have 2 pieces of cake and you want to share them. That means divide. You want to divide them between 20 billion people. A lot. 0. So the limit as x goes to infinity of k is 0. Look at what you're up against and argue it through. You have a fraction and you want to know when it's the most. It's the most when, assuming everything's positive, it's the most when the denominator is the smallest. Okay, let's try the same thing for y is equal to ln of x. So y prime will be 1 over x, and y double prime will be negative 1 over x squared. So the curvature is the absolute value of y prime, which is 1 over x squared, divided by 1 plus y prime squared, which is 1 over x squared. And this is all to the 3/2 power. Okay, let's clean up the bottom. So it's 1 over x squared over. I'm going to think of that 1 as x squared over x squared. So it becomes x squared plus 1 over x squared. Yes, to the 3/2 power. So I keep the top the same. I change division to multiplication, and I flip over the bottom. All to the 3/2. But that's 1 over x squared times the numerator to the 3/2 power, which is x cubed, divided by the bottom, x squared plus 1 to the 3/2 power. Can't really do much for that. That x squared goes into x cubed, x times. The numerator is the result of 1 times x, and the bottom is x squared plus 1 to the 3/2. That's what k equals. K is equal to x over x squared plus 1 to the 3/2. Now I want to find out what the most that is. Now since the numerator is not just an ordinary constant, here I think maybe we should take the derivative and set it equal to 0. Okay, so let's write this down. K is equal to x over x squared plus 1 to the 3/2. the k prime. So k is a quotient, so I'm going to use a quotient rule. The derivative of the top is 1 times the bottom. Minus the top, x, times the derivative of the bottom. Keep the x squared plus 1 the same. Bring down the power, make the new power 1 less. Then multiply by the derivative of what's inside there. The numerator is done. Then you square the bottom. You have something to the 3/2, and then you square it. Well, there's a something. When you multiply the exponents, the 2's cancel, and you get the something cubed. That is, it's x squared plus 1 to the 3rd power. Okay, let's clean this up and see where it equals 0. The 2's over here cancel out. So you get 1 times that is x squared plus 1 to the 3/2 minus 3 times x, x squared, times this piece, x squared plus 1 to the 1/2. And this is all over x squared plus 1 cubed. You can now there's an understood 1 here. You can factor out x squared plus 1 to the 1/2. And when you distribute, you want to get 3/2. So you get x squared plus 1 to the 1. When you add the powers, you get 3/2. Minus 3x squared, because this is exactly what you factored out. And all of this gets divided by x squared plus 1 cubed. First we'll talk about this. They're the same base. The larger power is on the bottom. So you do 3 minus 1/2, which is 2.5, which is 5/2. That's what you have on the bottom. On top, you have the plus 1, and you have x squared minus 3x squared, which is minus 2x squared. And now you want to know where either this is 0 or undefined. It's undefined when the bottom is 0. But the bottom is at least 1. It'll never be 0. So this is equal to 0, a fraction is 0, when the numerator is 0. 1 minus 2x squared. Let's try to solve that right here. If you subtract 2 things and you get 0, you should immediately say those 2 things equal one another. Divide by 2, you get x squared is 1/2. Take the square root, you get x is plus or minus 1, the square root of 1 is 1 over the square root of 2. But 1 over the square root of 2 is square root of 2 over 2. Now, we want the max. If x is negative, let's go back to the very top. If x is negative, the numerator is negative. But the denominator is always positive. You square a number, you're going to get at least 0. You'll never get negative. When you add 1, you'll be positive. When you raise it to the 3/2 power, it's positive. It's going to be negative if x is negative. But if x were positive, you get a positive answer. That is why I'm going to reject the negative square root of 2 over 2. I claim that we have a max at square root of 2 over 2. Now, if you want to know what that max is, well, just plug it in. The numerator is the square root of 2 over 2. The denominator, x squared. Now remember, x came from, excuse me, doesn't matter. We have what x squared is. It's a half. It's a half. Okay? It's a half. You add 1, you get 3 halves. And now we have 3 halves to the 3 halves. We have the square root of 2 over 2 times 2/3 to the 3 halves. Which means 2/3 times the square root of 2 over the square root of 3. The 2's cancel. Square root of 2 times square root of 2 is 2 over 3 square root of 3. Multiply top and bottom by square root of 3. You get on top 2 square root of 3. At the bottom, square root of 3 times 3 is 9. Times another 3 is 18. And then I wish I had the room, but then you get square root of 3 over the number 9. Square root of 3 over 9. That will be the max. Okay. A lot of work. But for real, it's all Calc 1. It's all Calc 1. It's, if you're not doing well in this material, we can't blame it on, Calc 3 is hard. No. This is Calc 1 material. Go back and learn Calc 1 and then tell me this is hard. And now, the second part of this was to find the limit as x goes to infinity of k. That is, to find the limit as x goes to infinity of x over x squared plus 1 to the 3 halves. Okay, now, if you plug in, you get infinity over infinity. There's 2 ways to proceed from here. You can use L'Hopital's rule, but that involves taking the derivative of the bottom. What you can do, if you want to be slick, is so the top is just x. Now, to be real slick, if x is super large, then you square it. Adding to 1 doesn't do anything. Adding to 1 doesn't do anything. I mean, if somebody owed you this amount of money, $1 million squared, plus 1, okay? And they actually paid you, but they kind of shorted you a little bit. They only gave you the million squared. They didn't give you the 1. I don't think you're going to say a word. That is, it's just like when x is super large, and it is, it's going to infinity. What's in that bracket is just x squared. You have to raise it to the 3 halves power. Now that was a lot easier than using L'Hopital's rule. I'm just saying ignore the 1. So the numerator is x, but x squared to the 3 halves, that's x cubed. And now we just do one calculation. We reduce this. We get 1 over x squared, and we say 0. 1 divided by really large squared. That is 1 divided by really large, really little. It's approaching 0. It could be that k is an increasing function. So the max that k can be is when x does tend to infinity. Okay, let's look at another type of problem. Okay, suppose you wanted to find the points where the curvature is 0. Y equals x minus 1 cubed plus 3. where is the curvature equal to 0? Well, we need to find the curvature. Now remember, since y is a function of x, the curvature is, oh, actually, I was going to say maybe this wouldn't work, but of course it will work. A fraction is 0 when the numerator is 0 and the bottom is not. The thing with the bottom is it'll never be 0. Remember, if you have x to the 3/2 and it's 0, that implies that x was 0. Okay, if you raise stuff to the 3/2 and you get 0, that means that stuff had to be 0. That means this has to be -1. Because you tell me 1 plus what gives you 0. So there's no way that's not 1. That's 1. Y prime squared would have to be -1. But that never happens. The bottom will never ever be 0. That is, just setting the top equal to 0 is enough. We just have to set the top equal to 0. That is, we find y double prime, find the absolute value of it, and we say, hey, let's see when it equals 0. Who knows? Maybe it never equals 0. Y prime is, you have a function to a power. Keep the function the same, bring down the power, make a new power and one less. Then take the derivative of what's in there, which is 1, and multiply it by that derivative. So you don't have to multiply by 1. It doesn't do anything. The second derivative, you have a function to a power with a constant in front. Don't worry about the constant. Don't have to use the product rule. Don't. 2 times 3 is 6. That is, bring down the power, make a new power 1 less, and take the derivative of what's inside. 6 times 1 is 6, times x minus 1 to the 1 is, it is just x minus 1. There is y double prime. And we set it equal to 0. If this times that equals 0, then either 6 is 0, which is absurd. 6 never, ever, ever equals 0. Students are always telling me, when x is -6, 6 is 0. That's crazy. 6 equals 0? No. Maybe 6 plus x, when x is -6, is equal to 0. 6 doesn't equal 0. But x minus 1 does. It happens when x is 0. When x is 1. If you wanted to find the y value, 1 minus 1 is 0. Cube 0 gets 0. Add 3. So the curvature is 0 and 1, 3. And we never spent 1 second, 1 moment at all figuring out what the bottom is. You need to be mathematically mature enough to know a fraction is 0 when the numerator is 0 and the denominator is not. That denominator is never 0. It's always more than 1 or equal to 1. Okay, we have this other formula to find the curvature. When you have r as a function of theta, the curvature is 2 times r prime squared minus r times r double prime plus r squared divided by r prime squared plus r squared to the 3 over 2 power. So suppose you come to know that r is 1 plus cosine theta. Alright, this formula says you need to know R double prime, and you need to know R prime. Sometimes you need to square these. So R prime is negative sine theta. And that's one of them that you need to square. So R prime squared will be positive sine squared theta. And R double prime, take the derivative of R prime, it is negative cosine of theta. And that one does not need to be squared. Okay. So you get 2 times R prime squared. You get 2 times that. I need more space. You get 2 times sine squared theta minus R is 1 plus cosine theta times R double prime, which is negative, so I change the sign, negative the cosine of theta, plus R squared. Okay, so let me just write that even more to the right. Plus R squared. 1 plus cosine theta squared. Let's now do the denominator. You get R prime squared over, you get R prime squared, which is sine squared theta, plus R squared. 1 plus cosine theta all squared, 3/2 power. Okay, let's clean this up. You have this, and you have positive cosine theta times 1, which is positive cosine theta, plus positive cosine theta times positive cosine theta, which of course is cosine squared theta, plus 1 plus cosine theta squared. You get 1 squared plus 2 times 1 cosine of theta plus cosine squared theta. All over sine squared theta plus 1 plus cosine theta squared is 1 plus 2 cosine theta plus cosine squared theta. All to the 3/2 power. Let's continue on top. Equals. I have 2 sine squared theta plus cosine squared theta plus another cosine squared theta, better known as 2 cosine squared theta, plus 2 cosine theta plus another cosine theta, plus 3 cosine theta, plus 1. And this all gets divided by the bottom. Okay, I'm just going to leave it that way for right now. Sine squared theta plus 1 plus 2 cosine theta plus cosine squared theta, all to the 3/2 power. Now, here you can factor out a 2, and you'll get 2 times sine squared theta plus cosine squared theta. That is, you'll get 2 times 1. You get 2 times sine squared theta plus cosine squared theta. But that's 1. You get 2 times 1, which is 2. Plus another 1 is 3. Plus 3 cosine theta. Yeah, that's the numerator. As our next step, I'll factor out the 3. But for now, that's the numerator. The bottom, sine squared theta plus cosine squared theta is 2. So you get 2 plus another 1. excuse me, I don't know what I'm thinking. Sine squared theta plus cosine squared theta is 1. Plus another 1 is 2. Plus 2 cosine theta. Of course, that gets raised to the 3/2 power. In the numerator, I can factor out as 3. I get 1 plus cosine of theta, which happens to be r. And in the bottom, yes, it's all raised to the 3/2, but I can factor out a 2. 2 plus 1 cosine theta. Okay, let us clean this up a little bit. Let's distribute this 3/2 power. Remember, these powers are understood to be 1. So we get 3 times 1 plus cosine theta divided by 2 to the 3/2 times 1 plus cosine theta to the 3/2. That's to the 1 power. With respect to the 1 plus cosine theta, the larger power is in the bottom. So that's where 1 plus cosine theta goes. And you subtract the powers. 3/2 minus 1. This is 1/2. You take away the 1, you get a half. And 2 to the 3/2. This is 1/2. So you get 2 to the 1 times 2 to the half. 2 to the 1 is 2. 2 to the half is the square root of 2. So you get this. 3 over that. Okay, 3 over that. What you can do is you can multiply the numerator by square root. You can multiply by 1. You want to change the way something looks, you multiply by 1. Multiply the top by square root of 2 and the bottom by square root of 2. When I multiply the bottom by square root of 2, square root of 2 times 2 is 2, times another 2 makes it 4. So I can put a 4 on the bottom. And I don't know if this is customary, but 1 plus cosine theta is r, so you get the square root of r. R to the half. And here is an answer, and here is an equivalent answer. But yeah, that's fine. I was thinking I changed from polar to rectangular. No. In polar, 1 plus cosine theta is polar, and so is r. R equals 1 plus cosine theta. Let us try one more. Actually, we'll try 2 more, then we'll be done. Suppose r is a sine theta. So r prime will be a cosine theta. R double prime, negative a sine theta. Remember that k is equal to 2 times r prime squared minus r times r double prime plus r squared divided by r prime squared plus r squared all to the 3 over 2 power. Well, 2 times r prime squared will be a squared cosine theta squared minus the product of those 2. But that product is negative, so it becomes plus a times a sine theta times sine theta plus r squared, which is a squared sine squared theta. And this all gets divided by r prime squared. Here's r prime. I square it. I get a squared cosine squared theta plus r squared. That's r. Square r, get a squared sine squared theta. And this is all to the 3/2 power. Okay. In the numerator, I'm going to keep the 2a squared cosine squared theta. I'm not going to do anything to this piece. But these two pieces are the same, and I'm adding them. So I get positive 2a squared sine squared theta. And in the bottom I have just what I have. Okay, in the numerator I can factor out 2a squared. And what's left over, cosine squared theta plus sine squared theta. But that's 1. 2a squared times 1 is 2a squared. So let's get rid of that. Just 2a squared. And within the big brackets, I can factor out a squared. And then I'll get cosine squared plus sine squared, which is 1. A squared times 1 is a squared. That is, I don't need this. In fact, I can close the brackets a little bit closer and raise it to the 3/2 power. So the numerator is 2a squared. The bottom, you multiply 2 times 3/2, and you get a cubed. And a squared goes into a cubed 8 times. And the final answer is 2/8. The curvature is 2 divided by 8. Tell me what a is, I'll tell you the curvature. Let's try one more. This one looks like it might be really easy. Remember that k is 2 times r prime squared minus r double prime plus r squared, divided by r prime squared plus r squared to the 3/2. Here they tell us r is equal to e to the theta. This is an easy one because r prime will be the same and r double prime will be the same. So wherever I see r and r prime or r double prime, just e to the theta. So it's 2 times e to the theta squared minus e to the theta times e to the theta plus e to the theta squared, divided by e to the theta squared plus e to the theta squared to the 3/2 power. E to the theta squared is e to the 2 theta. So we get 2e to the 2 theta plus this, which is e to the 2 theta, plus this, which is e to the 2 theta. Don't ask me why I put a plus there, that's a typo. In the bottom, we have e to the 2 theta plus e to the 2 theta again, so we have 2 of them raised to the 3/2 power. Okay, we have 2 or something, like e to the square thetas, and you take away one of these things, you have 1 left, and then if you add back 1, you have 2 of them. So you have 2 e to the 2 thetas, divided by 2 to the 3/2, and e to the 2 theta to the 3/2, you multiply the 2 theta by the 3/2, and you get 3 theta times e to the 3 theta. Okay. The 2 and the e go in the bottom, because the powers in the bottom are bigger. Yes, 3 thetas, you take away 2 thetas, you just have 1 theta. You have 3 over 2, which is 1 over 1.5, it's 1.5, and you take away 1, you get a half. So I have 1 over the square root of 2 e to the theta. Top right, please. 1 over square root of 2 e to the theta. If you don't like square roots in the bottom, fine. Square root of 2 times square root of 2 is 2. 1 times square root of 2 is square root of 2 times e to the theta. Either or. Okay, it's a long section, but we are done. In fact, we're done with the whole chapter, which, by the way, was entitled Vectors and Curves in the Plane. Okay, good luck with it. You can do it.